So before we go, I want to do one last question. Now this question involves like lots and lots of the skills that we've learned so far, so it's a great question to do at the end, and it also throws in one more very important concept. The test oftentimes likes to put you in situations where the question is all about like ratios or fractions or percents, but the answer that it wants is an actual real hard number. So we have to learn how to go from the land of ratios, percents, and fractions into the land of actual real numbers. And there's a specific way we do this, and this question is a great example of that. Let's take a look.
Okay, this is pretty much the perfect work rate question, which is to say it is pretty much the perfect quant question. It is just chock full of quantitative goodness and also has a key inference that the test will expect you to recognize, and this is really going to help you. If you can do this one, and you can totally do this one, you'll be able to tackle any work rate question the test can throw at you, and your overall quant skill is also going to go way up the learning curve. All right, what do we have? Okay, working together, Ace and Joanna can create a presentation and put their boss's name on it in 48 hours. Working alone, Ace can do the job in 120 hours. If Joanna finishes 2 slides more per hour than Ace, how many slides are in the presentation? Okay, first, what are we being asked? How many slides are in the presentation? Hey, what? Well, that's different. Usually we're asked for something like, well, what's the rate or the time or the work? Not exactly sure what to do with this, but the key is always not to panic. We'll just write it down and we'll put it over here, and we will just keep on using our excellent framework, which is always right, to guide us down our path. We just keep doing the next step, and the next step is always we write rate times time equals work. That always goes on the top. And who is doing the work? Well, we have Ace, Joanna, and together. That goes down the left side. All right, now what are we told? Well, let's see. Ace does the job in 120 hours, so Ace does one work, his time's 120, so his rate must be 1 over 120. And remember, the important thing in rate questions, especially when you're not exactly sure what's going on, is to get the rates. Now, we're also given some information about them working together. They can do one presentation, and their time for that is 48 hours. That must mean that their rate together is 1 over 48, and we are doing great. But I'm getting just a little bit itchy because we're not quite sure what's going on in this question, and we don't have everyone's rate. We still need Joanna's rate. Is there any way to get her rate? Well, let's see. Well, we know that we can add up rates. So we know that Ace's rate plus Joanna's rate must equal the together rate. So that must mean that the together rate minus Ace's rate must equal Joanna's rate. It is our friend the Lego inference. I told you that is everywhere on the test. Okay, so we're just going to need some common denominators if we want to subtract together from Ace. Ace's rate is 1 over 120, which is the same as 2 over 240. Together is 1 over 48, which is the same as 5 over 240. So Joanna's rate must be 5 over 240 minus 2 over 240, or 3 over 240. Excellent work. We now have everyone's rate, and we can now turn our attention to what exactly we're being asked for again? The number of pages in the presentation? Well, how do we do that? And what is this business about Joanna finishing 2 slides more per hour than Ace? And why doesn't the number 2 fit anywhere into our chart? As it turns out, those are excellent and important questions. So it is very important to realize that every number in this chart lives in the relative land of ratio, percents, and fractions. I mean, all we're doing in these work charts is taking an arbitrary one work. One work doesn't live anywhere on the number line. And then we just chop up that one work into little ratios. And that works great if we're being asked back for a ratio, like time, which is work over rate, or rate, which is work over time. But if we're being asked for an actual real hard number that has actual meaning in the real world, like the number of pages in a presentation, then we need to cross the bridge from the land of ratios, percentages, and fractions to the land of real numbers. How do we do that? Glad you asked. Like this. Okay, so we start from our land of ratios, fractions, and percents, and we want to end up in the land of real numbers, we need a bridge. And to cross this bridge, we need a real actual number to work with. And this is super important. If the test ever expects you to go from a bunch of ratios to an actual number, you must be given a real hard number to work with, or else you can't do it. And in this case, we are. We are told that Joanna finishes 2 slides more per hour than Ace. We're given the number 2 slides. So our next move is to figure out exactly what that 2 means in math. All right, it says English and math. Well, per hour means rate. So this 2 must be some sort of rate. We also have more. Here's the thing, and this is not the most intuitive translation. Words like more or taller or faster, as it turns out, means subtract in math. I know it doesn't necessarily make sense, so let me give you a couple of examples so you can see how this works. So if you have $50 more than me, we take all the money in your wallet, subtract it from all the money in my wallet, and the result will be $50. If my brother is 2 inches taller than me, which he is, and I don't like to talk about that, then we take my brother's height, subtract my height, and the result will be 2 inches. So if we know that Joanna is 2 pages faster than Ace, then it must be that Joanna's rate minus Ace's rate equals 2 pages. I know that's slippery. Now, here is the brilliant part. We can express Joanna's rate minus Ace's rate in terms of this real number. That equals 2 pages. We can also express Joanna's rate minus Ace's rate in terms of our ratios, because we know that Joanna's rate is 3 over 240, and we know Ace's rate is 2 over 240. So when we subtract those, we know that Joanna's rate minus Ace's rate is 1 over 240. So if a rate of 2 pages per hour equals Joanna's rate minus Ace's rate, and if Joanna's rate minus Ace's rate also equals 1 over 240, then we can set 2 equal to 1 over 240. 2 pages per hour must equal a rate of 1 over 240. That means 2 pages is equal to 1/240th of the entire presentation. This is excellent. Now, let's step back for just a second and see what we've done. So we were given a real hard number, 2. And we set that equal to Joanna's rate minus Ace's rate because that's what we were told the 2 meant. Then we figured out which one of our ratios was also equal to Joanna's rate minus Ace's rate. Because the 2 was equal to Joanna's rate minus Ace's rate, and our ratio was also equal to Joanna's rate minus Ace's rate, we were able to equate the number 2 with our ratio. I know it seems a little strange at first, but as you practice this, it will get easier, I promise. Okay, now back to our regularly scheduled question and finish up. So we know that 2 equals 1/240th of the total presentation, so we know that the total presentation must equal 480 pages. That is excellent work. Okay, I would like to take just a second to emphasize. Was any of the actual math, the actual arithmetic or algebra in this question hard? No. A 4th grader could have done all the computations, but this question was like really hard. What made this question hard and what makes all of these questions hard? Well, it isn't the math. This is not really a test about your math. What made this question hard is you had to nail the Lego inference so you could get Joanna's rate. You had to realize that you had to cross the bridge from ratio to real numbers. You had to be able to translate the phrase 2 slides more per hour into math, and then you had to figure out which ratio corresponded to that English into math. The entire test is primarily built on these frameworks and spotting these inferences. So the sooner you can feel more comfortable not just, hyper-focusing just on the math and the arithmetic and algebra, and start to pay closer and closer attention to how the questions are actually put together and identifying the patterns in the question that lead you to the right inferences, the sooner you'll start scoring really big scores on the test. And we're going to keep practicing those very skills in every lesson, and you're going to keep on getting better and better. That was excellent work. This was a really hard question. If you found it challenging, and let's face it, everybody finds it challenging when they first encounter it, do this question over and over, like 3, 4, 5 times. There's tons of learning in this question. I guarantee it's going to make you better.